All right, I'm going to solve some quadratics by graphing. So we have x squared plus 2x is equal to 8. I'm going to show you how these types of equations can be solved using a graph. The most important thing that most people forget about is we want our equation, the entire equation, set equal to 0. Once it's set equal to 0, things become a lot easier and it allows us to get to our answer much better. So right now I have x squared plus 2x equals 8. Do not have a 0 on the other side. So in order to get a 0 on the other side, what I'm going to do is I would like to move this 8 over to the left side. So I'm going to subtract 8 on the right side. If I subtract it on the right side, I got to subtract it on the left side. And when I do that, I'm going to get x squared plus 2x minus 8 equals 0. X squared plus 2x minus 8 is equal to 0. I got it equal to 0. This is going to allow me to do a lot of things. So we are going to solve this by graphing. So what I'm going to do is I'm basically going to take this x squared plus 2x minus 8, and we're going to imagine it is equal to 0. Or sorry, equal to y. So I'm going to use my graphing calculator to help me get through how to graph this by hand, and then we'll look at what in the graph allows us to solve this. So to graph it, we're going to go to y equals, and we're going to type in x squared plus 2x minus 8. The y equals button, x squared plus 2x minus 8. To graph it, top right is the button to graph. Now this is the graph I have, which is great. I see a lot of things here that are important, and we'll talk about more what's important in this graph when we have it on my paper. But I now want to graph this. To graph this, I like to use a table of values where each line is another coordinate on my graph. So to get a whole table of values, what I want to do is above the graph button in blue, it says table. So I'm going to hit second table. And what I'm looking for is, since I'm doing with an x squared, a quadratic, I know there should be some repetition here, some numbers that repeat. So if you scroll up and down, I'm looking at the y values and looking for repetition. I can find that right here, if I look at my y values, they all repeat. I have a 0, negative 5, negative 8, negative 9, negative 8, negative 5, 0. So I have that repetition I was looking for. So I'm going to copy this down in my table. So I have negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 0, 0, negative 5, negative 5, negative 8, negative 8, negative 9 in the middle. And every single line here is a different coordinate on my graph. So negative 4, 0 is right here. Negative 3, negative 5. So left 3, down 5. Negative 2, negative 8, right there. Negative 1, negative 9, 0, negative 8, 1, negative 5, 2, 0. And we can add more points in if we want to. You aren't limited to just the points in your table. So what you could do is go up and down in your graph. So like, for example, I went up to negative 5, 7, which is not in here, but I could still add it to my graph. I think it helps provide a little bit more complete of a picture for you so you can see what's going on. So I have negative 5, negative 7 added in there, and on the opposite side it would be 3, 7. So when I trace this, my parabola comes in with this graph here. So I have it entirely traced in there. So now I have my graph, and using this graph, we can solve this quadratic by graphing. Here's kind of the math reasoning behind it. So I graph this with a y here instead of a 0. So what happened is my 0 is actually y. So what I want to look for is, when is my y ever 0? Well, you can look at it on the table and graphically. So when is my y ever 0? Since I switched out the 0 for y, that happens at negative 4, 0, and 2, 0. And if we look at those points on the graph, negative 4, 0 is right here, 2, 0 is right here. So what we are looking for is we're looking for the x-intercepts. We're looking for the x-intercepts for our solutions. But more importantly, all we want to know is what x values does my graph intercept when y is 0. So when that happens is when we have x equals -4 and x equals 2. So we have -4 and 2 as my two x-intercepts. We don't care about y. Reason being is if you look in the original equation, there is no y value there. I only care about x being -4 and x being 2. Now, one thing I like to do is I like to check my work to make sure these numbers are right. So we're going to check back and plug into the original equation, which was x squared plus 2x is equal to 8. So what I'm going to do is I'm going to take this -4 and I'm going to plug it in on the left side and see if I get 8 equals 8. So I'm going to plug it in and replace all x's with -4. So we're going to have parentheses squared plus 2 parentheses equals 8. So I'm plugging in -4. I'm plugging it in. I like to plug it in with parentheses. And notice the parentheses are in the spot of the x's. So parentheses squared plus 2 times parentheses equals 8. So if I plug in -4, and you could check this on your calculator, type it in just like this. And what's going to happen is you're going to get 8 equals 8. So it works out. X equals 4 is a solution. And you would do the same thing now with 2. Figure out 2 squared plus 2 times 2. And see, it does that equal 8. And what happens is you plug it in, you get 8 equals 8, works out. So x equals 2 is also a solution. And that was solving quadratics by graphing. Other things that can happen that I want to touch on that this example doesn't touch on is you can have different graphs do different things. So 2 other examples is sometimes you'll have a quadratic, and it could come from the bottom too. It's going to come up, and the vertex is on the x-axis, and that's the only piece. So what can happen is, say this is 1, 2, 3, 4, at x equals 5. You can have one solution whenever the graph only touches the x-axis one time. You could also have another case where you graph your parabola and it's never, ever, ever going to intercept the x-axis. And when that happens, it is no solution. So these other situations, when you look at the graph, can happen too. So you have one solution, no solution, or in our example up here, 2 different solutions.